Hello, I'm Jyoti, and today we are going to discuss about the refraction of light, which is a very basic and a very common phenomena that we see every day in our life, whether we are looking deep into the sea or we are looking towards the sky. So, before going to start this very interesting topic, let me discuss or let me show you a very small and simple activity that you can also perform in your home to observe the effects of refraction when the object is passing through different mediums. So first, let me take this empty beaker. So I'm having this empty beaker, and now when I'm putting this pen into this beaker, I'm not showing, it does not show any change in its shape. But when I start pouring water into it, when I start pouring water into it, so all you can see, there is bend in the pipe. So this is why, because of refraction. Now there are two medium present in this glass of water. One is air and another one is water. So when the light is passing from two different medium, it shows a refraction. Similarly, when I dip this simple pendulum or this object into this water, so you can see that there is wideness in its shape. When I removed it out, it will come back to its original shape. When I dip it, it will again becomes wider. This is also an effect of refraction. Now, I will also show you that diffraction can change the direction also. Let me show you this arrow. The direction of this arrow is towards left side. But when I pass it through the water, it will appear to be moving towards the right. This is the effect of refraction. So, from observing these activities, we can now conclude that refraction is what which can change the shape of the object, which can change the direction of the arrow, which can show you, or which will show you that the pen appears to be bent when it is dipped in the water. So what actually is refraction? Refraction is the phenomena. What is refraction? Is the phenomena due to which the light bends when it is passing from one medium to another medium. And the cause behind the refraction is because of the different speed of the light in different medium. Suppose if I say the speed of light, if I say the speed of light, speed of light in air is 3 into 10 raised to power 8 meter per second. But when it passes through water, it becomes speed of light in water, it will become 2.25 into 10 raised to power 8 meter per second. And when it is passing through glass, when it is passing through glass, it will become 2 into 10 raised to power 8 meter per second. So this is how you can see there is change in the speed of light when it is passing from air to water to glass. And this is why it bends when it is passing from different mediums. This is here we have taken the examples of transparent medium because light can only travel through a transparent medium. It cannot pass through an opaque object. So these air, water, glass and all are transparent medium, and when the light is passing, it bends either towards it or it will bend away from the path. Why it will bend towards the path, its original path, or it will bend away from its original path? It depends upon the speed of the medium. So light travels with different speeds in different medium, and this is all because of the different optical density. Optical density, we'll discuss it later on. Now, when the light enters into a denser medium, it slows down and bends towards the normal. Bends towards the normal, so I'll show you the picture. This is the picture of refraction. So this is the picture of a refraction, just a small this is your incident ray. When the light is falling on a surface, this light known as incident ray, but it moves to another medium, it bend maybe towards its original path or away from its original path. This is known as diffracted ray. The and the line drawn perpendicular to this surface is known as normal. The angle between normal and incident ray is known as angle of incidence, and the normal between refracted ray and normal is known as angle of refraction. And this angle of refraction depends whether it is an optically denser medium or it is optically rarer medium. So how will you decide whether it is optically denser or rarer? So just take an example of air and water. So air is rarer and water is denser. But when we compare water and glass, then water becomes rarer and glass becomes denser. So when the light passes to the denser medium, it slows down and it will bend towards the normal. And when it is passing through a rarer medium, it speeds up and it will bend away from the normal. Next we'll come to the laws of refraction. So this is the two laws of refraction. So one says, this is a very important law which says that whenever the light is passing from one medium to another medium, it's give you a relation between the a speed of light between those two medium, and that the speed of light, or you can say sine of angle of incidence to the sine of angle of refraction, is always a constant, is always a constant value, and this constant is also known as diffractive index of the second medium with respect to with respect to first medium. This is a very important law which also known as the Snell's law. This says that the angle of incidence to the angle of refraction is always a constant value. That constant is generally we represent with the symbol nu, and this is known as refractive index of the second medium with respect to first medium. For example, if this first medium is my air and second medium is my glass, then this refractive index is written as refractive index of glass with respect to air, and this is also equal to speed of light in first medium to the speed of light in second medium. Okay, so this is the refractive index, the formula of refractive index. You can use this formula if you know the angles between those two. I can use this formula, and if I know the speeds in different medium, I can use this formula. And the second law is the incident ray. That means this incident ray, this refracted ray, and the normal, this is your normal, all will lie at the same plane. So these are two normal examples of laws of refraction. Next, move to the next topic, that this is next is okay. Now the next is, does light always bends when it is passing from one medium to another medium? As we say, the diffraction is means whenever the light passing from one medium to another medium, there is change in its direction or bending of light. But if I say you that light does not always bends when it is passing from one medium to another medium, and how can I say this? Just take this example. When the light is passing through this glass, when the light is passing through this glass, light is traveling from air to water. Light is traveling through air. This is your air and this is your water, but still there is no bending, as I can see that the light is going straight. So this is just a special case of refraction where the light is does not show any kind of bend when it is passing through different medium, and that is only possible when your angle of incidence is equal to 0 degree. This is the only special case. When the angle of incidence is 0 degree, the angle of refraction also becomes 0 degree and the light will not show any kind of bending. This is the only case. Any other case, that means with any other angle of incidence which is not equal to 0, that angle of refraction is never equal to 0. So this is the case that I want to discuss with you. Next we'll discuss the diffraction that we observe every day in our life. There are the so many cases, or you can say every day whenever you are looking, everywhere there is refraction. Whether it is your rainbow formation that we have already know about it, that is a dispersion. When the light is passing from prism, it will splits into 7 colors. That is also a one case of refraction. This is again, this is also a special case. Why? Because when the light is passing only through a prism, then it will throw a rainbow formation or dispersion. Similarly, we are having magnifying glass, that is your convex glass. So that things becomes, or things appears to be big, like just like the bob, when I dipped into the water it becomes wider. Similarly, the magnifying glass, the things becomes bigger. Now fish in water, that apparent position of fish under the water is different from its actual position. That means whenever you look into the water, the depth of the or the bottom of the pond will appear to be raised. Why? Because of refraction. So these are the very common phenomena that we see, are the examples of refraction in our daily life. So just a small introduction of refraction, that what do you mean by refraction and what it can do in your daily life, and if it is not there, then what will happen. So just the conclusion is how it is playing a very important role in your life, whether if you are looking into the water, or you are looking to the sky, or you are observing anything through the water, or through the glass window, or through the glass pan, everywhere we are using refraction. Now by using refraction or the fundamental, this is the takeaway for you. Just what you can do, that by discussing the fundamentals of refraction, we can involve, or we can discover new technologies by using this refraction. I hope I have made my some points clear. Thank you so much. Hari Om.